Hi, in this lesson, I'm going to show you how to solve a system of equations using the substitution method. Before we get to actually solving a system of equations, not that this isn't one, but I want to show you a little example of something that you've done in the past. So what I'd like you to do is maybe push pause, figure out the value of y for this problem by using substitution. All right, now I'm going to show it to you. All we're going to do is we're going to take y equals 2. Now, instead of writing the x, since we know what x equals, we'll put the 3 in there for it, and then add 6. So I just look at simplifying the right side. 2 times 3 is 6. Add on the 6, and we just figured out that y equals 12 by substituting the value of x equal to 3 into this equation. So we got y equal to 12. Now we're going to solve a system of equations using substitution. I'm showing you that there's kind of 3 steps to this. The first thing you're going to do is you're going to get one variable by itself in one of the equations. And it doesn't matter which equation, and it doesn't matter which variable. You pick. Then once you've done that, you're going to substitute its value into the other equation. And finally, we're going to solve for the other variable, which I think these steps get confusing until you actually start doing the steps. So let's do step 1. Get one variable by itself in one equation. Now what I'm going to encourage you to do is to take a look at the 2 equations you're working with and figure out which one's going to be easiest to get one of the variables by itself. Now in my first example here, it's really easy because the blue equation already has the y all by itself. I don't have to do anything. I'm done with step 1 before I even started. Now step 2, substitute its value into the other equation. So this is where it's saying, let's take what y is equal to, and let's put it into the other equation. And this is where I like to use circles and arrows. So I circle what the y is equal to, and then I draw an arrow to where I'm going to put it in the other equation. It's going to go right there. And now I'm going to take that second equation, the red one for me, and I'm going to rewrite it. But instead of putting the y there, I'm going to put the value of y, which is 2x minus 3. Now I have a new equation, and notice there's only one variable. It's x. You know how to solve an equation that has one variable in it that looks like this. So that's what we're going to do now. And to do that, we're going to have to distribute. So we have the x plus, now, not 3. Let's try that again. How about 6x and then minus 9 equal to 5? At this point, I would add 9 to both sides of my equation. And then the left side, x plus 6x is 7x. Right side is 14. Divide both sides by 7, and we'll find out that x equals 2. So we just figured out the value of x, but we also need to figure out what's the value of y. Well, now we can do substitution all over again, similar to what we did on that previous slide. I now know what x is. I can take that x value and plug it into any one of the equations that has x and y in it. So I could plug it in here, or I can plug it in here. And it's up to you. I recommend picking the one that looks easiest for you to work with. To me, it's going to be easier or less steps to plug it into the blue one. So I go back to that blue equation. Y equals 2 times x, but x is 2, and then minus 3. Well, now, this is, wanted that to be a different color, 4 minus 3, and 4 minus 3 is 1. So we figured out that the y value is 1. And we've just solved our system of equations using substitution. X is 2, y is 1. We could put that in terms of a point as well. So we could display our answer in a point format this way, or as the x and y value. Now, the reason that I have the graph above is to show you that if I solve it using substitution, or I solve it using the graphing approach, which we've done before, we end up with the same solution. Notice where they intersect is the point 2, 1. Now I know that I didn't take my red equation and put it into slope-intercept form, but had I, it would have graphed this line. It graphs that line and not in slope-intercept form, but it's a little easier to see it when it's in slope-intercept form. I've taken the liberty of going through and graphing it for you to show you that whether you solve it by graphing or solve it using substitution, we get the same solution to our system of equation. Now I have a second example here. Solve this system of equations with substitution. So again, remember, the first thing we want to do is get one of the variables all by itself in one of the equations. Now this one's not as nice, where I don't have y equal to something or x equal to something, so I have to pick. So I go through and I look at this. In my first one, I kind of have the y by itself, or just a single y, but it's a negative y, so I don't really like that. But I look at the second one, and I notice that it just have an x with a coefficient of 1. That's nice. So I can just, in one step, get this red equation to say x equals by adding 2y to both sides. And now we have x equal to 2y plus 3. And this is the point now where I'm going to circle what my x value equals, and I'm going to draw an arrow to where I'm going to put it, right there. And then I'm going to rewrite that blue equation. So now I have 2 times x, which is 2y plus 3, and that then minus the y equals 2. And I now solve this equation. So if I distribute, I'm going to have 4y plus 6 minus y equal to 2. I'm going to subtract 6 from both sides. And I now have 3y equal to negative 4. Now I have to divide both sides by 3. And I get y equal to negative 4/3. And you're going, why is there a fraction? Well, sometimes we get fractions in our solutions. So we just figured out the value of y is negative 4/3. And then we have to plug that into one of our equations. And again, it doesn't matter. Now here's the thing. You have all kinds of equations to pick from. We have this one that we could plug it into, we have this one we could plug it into, and we also have this one that we can plug it into. Now I personally like this last one because it already says x equals, and we're trying to find the value of x. So I'm going to put it into that one, which tells us x equals 2 times our y value, which is negative 4/3, and then we have to add 3. So we have a little fraction work here. We're going to have negative 8/3 when I multiply that together, plus 3. Well, now since I have to add fractions, I want this 3 to have a denominator of 3. That means it's going to have to be 9/3. 9/3 is the same thing as 3. Now, negative 8/3 plus 9/3 is going to put us at 1/3, which is the value of x. Now look at this. I solved it by graphing earlier. You've seen that the whole time. So it says my x value should be 1/3, my y value should be negative 4/3, which when we look at the intersection of those two lines, that's it. X equals 1/3, y equals negative 4/3. And we found our solution. Now remember, you could display that as a point also, and then it would look like this. So either way, written as a point for your solution or in terms of x and y, we have it. Now in this one, we have to solve our system again. This one's nice again because we already have one of those variables all by itself right here. And I'm going to take that y value and I'm going to put it into my equation right there. So now I have 6x minus 2, but not y. I'm going to put the 3x plus 2, and then that equals negative 4. And I work on solving this equation. So if I distribute here, I'm going to have 6x minus 6x minus 4 equal to negative 4. I'm going to simplify the left side of this equation, and that's going to turn out to be, well, 6x minus 6x is 0, so I have negative 4 on the left. The right side is negative 4. Now notice, my x's are all gone, and it now just says negative 4 equals negative 4. Well, what does this mean? Well, this tells us that these two equations are actually the same equation. In other words, they're the same line. And remember when we solve by graphing, which you see over here, when we had one line on top of the other line, we had infinitely many solutions. So for a situation like this, where you solve using substitution, but it comes out and it says a number equals the exact same number, you need to remember that we have infinitely many solutions. Oops. Solutions to that system of equations. There we go. Now in this one, I'm going to do the same thing, solve using substitution. This one's kind of nice where both equations already have the y all by itself. So it doesn't really matter which y you circle or value of y. So I'm just going to circle the blue. So this is what I like to take and put it in for y over here. And then remember, rewrite the red equation. Well, if I rewrite the red equation, I start with the blue from before. So I have now 5/3 x plus 7, and then equals 5/3 x minus 1. I want to get all my x's to one side, so I'm going to get rid of the 5/3 x, subtract the 5/3 x here, and now I notice that the left side of my equation says 7, and the right side of my equation says -1. Again, my x's all went away, but this time I have a number in 7, equal to a different number in -1. Well, what does that tell me then? Well, that tells me that my lines were parallel, or are parallel, which you can see from the graph, because we've solved using graphing before. And remember, when we solve by graphing and the lines never intersect, that means there's no solution. There's not an x value and a y value that I can put into both of those equations that will make both of them true. So that's going to conclude my lesson on solving using substitution. But I just want you to remember that there's kind of those three scenarios. There's the one scenario where the lines intersect, not that you're going to see it when you use substitution, but you're going to get an x and a y value, or you're going to find values for your two variables. But then there's the situation where we had like this one, where we got a number equal to the same thing, and that's going to tell you that there's infinitely many solutions. And then finally, we have this last situation where we got down to the point where a number equaled a different number, and that's going to tell us there's no solutions. And that will be the end of solving our systems of equations using substitution.